Welcome YouTubers to another episode in my Grammar Hero series. In today's video, we're going to start talking about triangles, which is a topic that has a very high likelihood of appearing on the mathematics knowledge subtest of the Armed Services Vocational Aptitude Battery. That is the ASVAB. More specifically, starting today and through the rest of the week, I plan on discussing some basic properties about all triangles, including the Triangle Sum Theorem. In addition, I'm going to talk about how to find the area as well as the perimeter of all triangles. And eventually, I'm going to discuss some properties of different types of triangles you have to know how to deal with on the ASVAB. Later in the week, I'm going to finish my discussion on triangles by devoting a large part of my discussion to right triangles, notably the Pythagorean theorem. I've structured this video like this. I'm going to give you, in the beginning, a basic overview of triangles. Then I'm going to do some very basic practice problems for what we talk about. And then in the very final part of this video, we're actually going to work on three practice problems that have a very high likelihood of appearing on the ASVAB and are actually very similar to the way the ASVAB is going to ask you questions. So again, I think that's one of the benefits of watching my videos and using my materials. Again, all my stuff's designed for the ASVAB, whereas, other websites are doing their own thing. So that said, let's go ahead and get started with today's video. Today we're going to learn to crawl before we walk, and that is, we're only going to talk about triangles in the most basic way. That said, as you'll see in a minute, even basic properties of triangles can create some pretty challenging questions. So to start today's video, I want to mention that all triangles have three sides and three angles. Okay, we should all know that already. And then the three angles inside a triangle always add up to 180 degrees. Not everyone might have known that fact. Well, if you take a look right here, this last fact is called the Triangle Sum Theorem. And again, it says the sum of the three interior angles of all triangles is always 180 degrees. And it gave you this formula: angle A plus angle B plus angle C equals 180 degrees. We're going to make use of this today. But that said, don't get trapped into thinking that these angles could just be called A, B, and C. I can call the angles angle 1 plus angle 2 plus angle 3, as long as those three angles add up to 180 degrees. So again, that's all we really need to know to do today's video. Using this information, let's do some practice problems. I'm going to do the first one to show you how it's done, and then once you get to number 2 and 3, or once we get to number 2 and 3, I recommend you pause the video, make an effort to work these out on your own, and then see if you and I came up with the same answers in the same way. So that said, for this one, we have to find out what the measure of angle F is. And again, according to the Triangle Sum Theorem, we were told angle A plus angle B plus angle C all add up to 180 degrees. And as I mentioned, don't get hung up on the fact that this has to be A, B, or C, because in this case, they gave us the variable F. So in light of that, I'm going to go ahead and rewrite this theorem in a way that makes sense to me. More specifically, I'm going to say angle D plus angle E plus angle F equals 180 degrees. Again, it satisfies all the requirements of triangles. We have three different angles that add up to 180 degrees. In this case, I'm going to call this one D, I'm going to call this one E, and this one's already labeled for us as F. So in light of that, it's just a matter of plugging these values into this equation and solving for the missing variable, which is F in this case. So again, I let D be 114, so let me write 114 in place of D. And I said E was going to be 31. Angle F is what we're trying to solve for, so we'll leave that as angle F. And again, this all equals 180 degrees. I'm going to drop off the angle symbol there as I do this arithmetic. So now the hardest part of these problems becomes doing the arithmetic. In this case, we're going to have to do some subtraction and addition. And again, there's no escaping that on the ASVAB. You don't get a calculator or a formula sheet, so you would have to know this theorem, and you would have to be able to do this arithmetic by hand. That said, let's go ahead and continue by adding 114 and 31 together, and I'm going to do that off to the side. Again, 114 plus 31. Okay, 4 plus 1 is 5. 3 plus 1 is going to be 4. 1 plus nothing is just 1. So, in other words, 114 plus 31 is 145. Again, that's plus F equals 180. I'm not going to skip any steps as I work these out. Again, in light of the fact that this is YouTube, I don't know who's watching this video and what their backgrounds are, so I'm going to do everything in order without skipping steps. All right, so again, I'm trying to get F by itself. So the next step is to subtract 145 from both sides. This will cross out, leaving you with angle F equals 180 minus 145. If you can't do that in your head, there's no shame in doing it off to the side. Let's go ahead and do that. 0 minus 5 we can't do, we have to borrow. This 8 becomes a 7. This 0 becomes a 10. 10 minus 5 we should all know is 5. 7 minus 4, of course, is 3. And 1 minus 1 is nothing. So we can see that this that measure of angle F is 35 degrees. Okay, so pretty straightforward once you get the hang of this. Go ahead and pause the video and try to work on number 2 and 3. As a reminder, this symbol right here indicates that this angle is 90 degrees. Okay. So again, whereas the Triangle Sum Theorem says ABC equals 180 degrees, we can see that we have X. So in light of that, I'm going to go ahead and make this make sense to me. So I'm going to write this as angle X plus angle Y plus angle Z equals 180 degrees. And again, this one's X. Let's call this Y, and let's call this one Z, just to make things easy. Again, we don't know what angle X is, so we'll leave that as is. Plus angle Y. Why let angle Y be 52 degrees? Plus angle Z, which is 64. And again, as we know, all of the angles in a triangle add up to 180 degrees. So now we're going to combine 52 and 64, which I'm going to do off to the side. 2 plus 4 is 6. 5 plus 6 is 11. So we can see that this is going to be angle X, which is unknown, plus 116 equals 180. Again, the next step is to subtract 116 from both sides to get X by itself. This is going to cross out, leaving you with angle X equals. And again, if you can't do this one in your head, there's no shame to that. Go ahead and do it off to the side. 0 minus 6 we can't do, we have to borrow. This becomes 7, this becomes 10. 10 minus 6 is going to be 4. 7 minus 1 is going to be 6. 1 minus 1 is 0. So we can see the measure of angle X in this case is going to be 64 degrees, which is right there. Okay, and we can see that this is in fact an isosceles triangle, and we'll talk about that in a later video. All right. So again, according to the Triangle Sum Theorem, angle A plus B plus angle C equals 180. In this case, we're given V, so I'm going to make things easier, I'm going to call this angle T plus angle U plus angle V equals 180. And I'm running out of space, so let me go back a little bit. so I can write that more clearly. All right, and let's just go ahead and call this T right here, U there, and angle V there. Angle T, as we can see, is 59 degrees. As I mentioned, this symbol right here indicates that that is a right angle. So we know angle U is going to be 90 degrees. We're trying to solve for angle V, the measure of angle V. So we know that this is all going to equal to 180 degrees. Let's combine 59 and 90. Again, if you can't do it in your head, there's no shame to that. We'll do 90 plus 59. 0 plus 9 is 9. 5 plus 9 is 14. So we can see that this becomes 149 plus angle V equals 180. Again, we're trying to find out what angle V is. So as our next step, we're going to subtract 149 from both sides. This will cross out, leaving you with angle, the measure of angle V equals 180 minus 149. Let's go ahead and work that out. All right, 0 minus 9 we can't do. We have to borrow. This becomes 7. This becomes 10. 10 minus 9 is 1, of course. 7 minus 4 is 3, and 1 minus 1 is going to be 31. So we can see the measure of angle V is 31 degrees. Now that we've done some basic examples using the Triangle Sum Theorem, let's take a look at some problems that are going to mirror what you're going to see on the ASVAB. Again, we have all the information we need in order to solve a problem like this. But as you'll see, this problem, unlike the first three that we did, involves combining your knowledge of triangles as well as some basic algebra in order to solve these. If you want to try this one on your own, you're more than welcome to. Once I do this first one, though, you should have the form down as to how to solve these, and you're more than welcome to pause the video in an effort to solve number 2 and 3 on your own. But that said, let's go ahead and get started. Question 1 says, in a triangle, if the second angle is 3 times the sum of the first angle and 3, and the third angle is the sum of 2 times the first angle and 3, find the 3 angles of the triangle. So unlike the first 3 problems, we're not given a nice diagram, and nor are we given any measures of the angles. So what I like to do when approaching these problems is to make my own diagram. So I'm going to go ahead and draw my own triangle here. Again, it doesn't say what type of triangle, so you can draw anything you want. And what it does say is the second angle is 3 times the sum of the first angle and 3. I'm going to have to represent that algebraically. So I'm going to have to let angle 1 just be x degrees. Again, I'm going to let this be angle 1. And in light of that, we know the second angle is 3 times the sum of the first angle and 3. So that's going to be 3x plus 3. And again, that corresponds to angle 2. And similarly, we know the third angle is the sum of 2 times the first angle and 3. So that's going to be 2x plus 3. And again, that's going to be our third angle. According to the theorem we talked about today, again, it was written like this: measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. I said not to get too attached to this form of the theorem because, again, you can substitute whatever you want in place of A, B, and C. And in this case, it makes sense to write this in place of it. Angle 1 plus angle 2 plus angle 3 equals 180 degrees. Again, it's the same thing as the theorem. I'm just using angle 1, 2, and 3 to refer to the 3 angles in a triangle. Okay, so again, as I mentioned, angle 1 is x. So let's go ahead and substitute x in for angle 1. Similarly, angle 2 is 3x plus 3. So let's substitute that in for angle 2. And finally, I mentioned angle 3 corresponds to 2x plus 3. So let's go ahead and write that in for angle 3. And again, this equals 180 degrees. Let's combine our like terms. As we can see on this left-hand side of the equation, we have x's and whole numbers. Again, our like terms are going to be x's. So let's go ahead and combine those first. X plus 3x is 4x, plus 2x is going to be 6x. And now let's combine the whole numbers, notably 3 and 3. 3 plus 3, of course, is 6. And this all equals 180 degrees. At this point, it should be clear that we're trying to solve for x itself. And in order to do so, our next step is going to require us to subtract 6 from both sides. This is going to cross out, leaving you with 6x equals 180 minus 6. And you can drop this angle symbol there if you want. 180 minus 6, we should be able to do in our head. That's going to be 174. And now in order to get x completely by itself, we're going to go ahead and divide both sides by 6. This is going to cross out, leaving you with x equals 174 divided by 6. As I mentioned in all my videos, all fractions can be regarded as division. More specifically, we can rewrite 170 over 6 as 174 divided by 6. All right, so again, now we got to do this long division. So we're going to ask ourselves to start, how many times does 6 go into 1 without going over? It doesn't, it's too big. How many times does 6 go into 17 without going over? 6 times 3 is 18, whereas 6 times 2 is 12. So we're going to have to go with 2 in this case. 6 times 2, as I just said, is 12. So we'll go ahead and subtract that away from 17. 7 minus 2 is 5. 1 minus 1 is nothing. Go ahead and drop down this 4. Now we're asking ourselves, how many times does 6 go into 54? 6 times 9 is 54. So 6 times 9 is 54. Therefore, we can see we have no remainder. In other words, x is simply 29. Okay, now the question asked us to find the 3 angles of the triangle. Again, I said angle 1 corresponds to x, so I know how many degrees are in angle 1. Can angle 1 correspond to x, which, as we can see right here, is 29, or more specifically, 29 degrees. Similarly, at the beginning of this problem, I said angle 2 corresponded to 3x plus 3. Now that we have our x value, we can substitute that in here to find out what angle 2's measurement is. So that's going to be 3 times 29 plus 3. And let's work that off to the side. Again, 29 times 3. 9 times 3 is 27. Carry the 2. 3 times 2 is 6, plus 2 is 8. So this becomes 87 plus 3, which is 90. Okay, so we know the measure of angle 2 is 90. And finally, angle 3, as we can see right here, corresponds to 2x plus 3. Again, substituting in 29 in place of x, we can see that becomes 2 times 29 plus 3. Let's go ahead and do the math off to the side. 29 times 2. 9 times 2 is 18. Carry your 1. 2 times 2 is 4, plus 1 is 5. Okay, so this becomes 58 plus 3. 58, 59, 60, 61 degrees. And if we were to sum this all up, we can see that this would in fact be 180 degrees. 29 plus 61 degrees would be 90 degrees, and then 90 plus 90 is in fact 180 degrees. So just like that, we found the measures of all the angles in this triangle. Again, using some very basic algebra to translate this word problem into an algebra problem using a small amount of arithmetic, as well as our knowledge of the theorem of the sum of angles and triangles. And we're done. So let's go ahead and move on to number 2. Again, number 2 and 3 are just like number 1, albeit with different variations. So if you want to pause the video and try to work this one out on your own, I recommend that you do that. Otherwise, let's go ahead and get started. Question 2 says, in a right triangle, apart from the right angle, the other two angles are x plus 1 and 2x plus 5. Find the angles of the triangle. Okay, so in this case, we're told we have a right triangle, which looks like this. And of course, this square corresponds to the 90-degree measurement in a right triangle. And it says the other two angles are x plus 1, so let's call this one x plus 1, and 2x plus 5, so let's call this angle 2x plus 5. And again, if it's helpful, I like to use this version of the equation, angle 1 plus angle 2 plus angle 3 equals 180. Again, the sum of all the angles in a triangle add up to 180. That's exactly what that says. And let's call this angle 1, angle 2, and we'll call this one angle 3. So now it's just a matter of plugging these things into the equation and solving for x accordingly. Again, I said angle 1 was x plus 1, so let's go ahead and write that in place of angle 1. Again, that's plus angle 2. Again, as I mentioned, this symbol indicates that this is 90 degrees, so we'll go ahead and write 90 right there. Plus angle 3, which I said was 2x plus 5, or which we were told is 2x plus 5. And again, that all equals 180 degrees. Let's combine like terms before we start moving things across the equal sign. Okay, we can see we have x here and x here. So x plus 2x, of course, is 3x. And then we have 1, 90, and 5. So that's going to be 1 plus 90, which is 91, plus 5 is going to be 96. Of course, this all equals 180 degrees according to the theorem. All right, so again, now we can start moving things across the equal sign. So let's start by subtracting 96 from both sides. That's going to cross out, leaving you with 3x equals 180 minus 96. Let's work that off to the side. Again, that's not an easy one to do in your head. 0 minus 6 we can't do. We have to borrow. This becomes 7. This becomes 10. 10 minus 6 is going to be 4. Now we're doing 7 minus 9, which we can't do. We have to borrow. This becomes 0. This becomes 17. 17 minus 9, of course, is going to be 8. All right, so we have 3x equals 84. Again, we want to get x by itself, so we're going to divide both sides by 3 as our next step. This is going to cross out, leaving you with x equals 84 over 3. And that's going to prompt us to do some long division, namely 84 divided by 3. Again, all fractions can be regarded as division. Now we're asking ourselves, how many times does 3 go into 8 without going over? 3 times 3, as we know, is 9, which is too big. 3 times 2 is 6, so we're going to have to go with 2 in this case. 3 times 2, as I mentioned, is 6. 8 minus 6 is going to be 2. We'll drop down this 4. Now we're asking ourselves, how many times does 3 go into 24 without going over? Well, 3 goes into 24 8 times evenly, given that 8 times 3 is 24. So we can see there's no remainder. Okay, so in this case, we know x equals 28 degrees, or 28. And again, this question says, find the angles of the triangle. And in light of that, we have to use this information to finish solving this one. Again, I said angle 2 corresponded with the right angle, so right away, I know angle 2, without doing any math, is going to be 90 degrees. Okay, angle 1, as I mentioned, corresponds to x plus 1. So where we see x, we can substitute this 28. So this is 28 plus 1, which is 29. So we know the measure of angle 1 is 29 degrees. And finally, the measure of angle 3 corresponds to 2x plus 5. Again, we can plug in this 28 in place of x, so this becomes 2 times 28 plus 5. And again, that's not an easy one to do in your head, so let's work it off to the side. 28 times 2. 8 times 2 is 16, carry your 1. 2 times 2 is 4, plus 1 is 5. Let's go ahead and keep working this out. Again, this is 56 plus 5. 56 plus 5 is going to be 60. That came out weird. 61 degrees. And again, if we take a look, if we add 29 and 61, that's 90. Plus 90 is 180 degrees. So we're pretty confident we did our work correctly in this case. Okay, so that's that one. Again, different variation of the first problem. In this case, you had to know that in all right triangles, there's a angle that's 90 degrees. We haven't discussed that yet, but I think it's something, that's pretty obvious. All right, question number 3, and this is probably the easiest question in this video. In a triangle, if the second angle is 2 times the first angle and the third angle is 3 times the first angle, find the angles of the triangle. So again, the problem doesn't specify that it's a right triangle, so we can draw any type of triangle that we want to illustrate this. And again, we're going to have to take this word problem and convert it to algebra that we can use to solve this one. It says angle 2 is 2 times the first angle. Again, I'm going to let this be my first angle, and I'm just going to call it angle x. And in light of that, if the second angle is 2 times the first angle, let's call this angle 2. We know this is going to be 2x. And similarly, if it says the third angle is 3 times the first angle, we know the third angle could be represented as 3x. Again, using the theorem, we know all the angles in a triangle, or according to the theorem, we know all the angles in the triangle add up to 180 degrees. That is angle 1 plus angle 2 plus angle 3 all add up to 180 degrees. In this case, we know angle 1 is x. Angle 2 is 2x, and angle 3 is 3x. Again, that's all 180 degrees, all adds up to 180 degrees. Let's combine our like terms, and in this case, all the variables are like terms. X plus 2x is 3x, plus 3x is 6x. Of course, that all equals 180 degrees. Now we're solving just for x, so we want to divide both sides by 6. And this leaves us with 180 divided by 6. Should be able to do this one in your head, given that 18 divided by 6 is 3, and we just tack on another 0. So this one's going to be x equals 30. Again, the question asked us to find the angles of the triangle. We know angle 1 corresponds to x, which is 30 degrees. We know angle 2 similarly corresponds to 2x. Since we know what x is, we can solve for angle 2 pretty easily by plugging in x accordingly. So this becomes 2 times 30. 2 times 30, of course, is going to be 60 degrees. And finally, we know angle 3 corresponds to 3x, which means that we can plug in x pretty easily and solve for the measure of angle 3. So this becomes 3 times 30. 3 times 30, we should be able to do in our head, is 90 degrees. 30 plus 60 is 90, plus 90 is 180, so we're pretty confident we did our work correctly. And we're done with this one. We did everything they asked. So again, that's all I have for you in today's video. I hope you like the fact that I took it from a very basic concept to some challenging ASVAB questions. Again, that's not something you get elsewhere, and I think that's what really helps people do well on the ASVAB when they watch my videos. As always, if you like my channel and the content I'm putting out, by all means, go ahead and subscribe. In addition, you're more than welcome to leave some feedback in the comments section below. Again, later this week, we're going to talk about these other topics I mentioned at the beginning of this video. So just stay tuned. But on that note, I'm going to go ahead and cut you loose. Konnichiwa.